Good morning, everybody. This is going to be the very first video that we're going to be looking at how chemical reactions come together. We're going to be learning the anatomy of a chemical reaction, and in the process to do this, we're going to have to learn how to bake some bread. And so I've brought with me an assistant. What's your name, sir?
My name is Daniel.
Daniel's going to help me and you learn how to make a chemical reaction by baking bread. Is that right?
Yeah,
Do you think it's going to be tasty?
it's gonna be really tasty.
All right. Well, we're going to find out here in a few minutes. So come along and join us as we bake bread and we learn how a chemical reaction is put down, right?
Yeah, you
Okay.
are exactly right. And thumbs up if you like this video.
All right. Now we've moved on to the kitchen. In here, we're going to look at all the ingredients we need to bake our bread. These are going to be 4 key ingredients: our all-purpose flour, our activated dry yeast, our salt, and water. The water needs to be warmed to a temperature of 32.2 degrees Celsius or about 90 to 92 degrees Fahrenheit. It looks like we are there. So, let's get started with what to do next. So now that we know what ingredients it takes to bake bread, we're going to have to add them together into their proper proportions. And what that means is how much of each ingredient are we going to need, and at what stages do we introduce them to one another. First, we have an instrument to help us with that. We have our scale. The scale is set to 0 grams. On top of the scale, we're going to put our mixing bowl. Now, our mixing bowl weighs something as well, so we're going to have to zero that out. Remember, in the lab, we call this tairing. So, we've taired our scale to 0 grams, and now we want to add 360 grams of water. Now, the water needs to be between 90 and 95 degrees Celsius, Fahrenheit. It needs to be about 32 degrees Celsius. So in this case, I've got my thermometer set to Fahrenheit, and we want 90 to 95 degrees Fahrenheit. And it looks like we're sitting somewhere comfortably right there. So we're going to add 360 grams of water to our mixing bowl. Almost there. That'll work. So, from here, we're going to add our flour. And we're going to add 500 grams of flour. So we'll hit 0 again on our scale. We're going to add 500 grams of flour. Now, if you go over, it's all right because the dry stuff is on top. So all we're going to do is just take a cup and pull off exactly what we need to get back to 500 grams. Okay. For the next step, you want this water and bread to what we call auto leaven. So we're not going to add the salt or the yeast just yet, but we are going to mix these 2 ingredients together until we have a nice wet dough. So by hand, just mix it around until you've incorporated all the flour and the water together. It will be sticky and it will be messy, but what we're looking for is to have no more dry ingredients in the container. This takes just a few minutes to get it there, but in the end, as you can see, we're left with a very sticky but very nice dough ball. Now that our flour and water have been incorporated together, we're going to let that sit in a process what we call autolysis, which allows for the natural yeast in the flour to start to incorporate itself with the water. We're going to let this happen for about 30 minutes. So I'm going to place a lid over this and set it aside with a timer. And we're going to let that sit and rest for 30 minutes. But in the meantime, we need to get our salt and our yeast ready to go. So I've brought out a different scale. This scale is more accurate than our larger scale. Our larger scale doesn't start to become accurate until about 4 to 5 grams. Now, with the yeast, we can only measure 2 grams. So we need something that's going to be more accurate. So we choose our smaller scale. We turn it on, and the first thing we're going to measure is going to be our vessel that's going to hold our salt. So in this case, we tare it again, and we need exactly 10 grams of salt. So in we pour, and again, if you go over, I've got 10.92 grams. We can remove it to get it back to 10 grams. Now, with our 10 grams, we also need 2 grams of our yeast. So we tare our vessel to get it to 0, and your activated dry yeast is very light, and this is why we're using our smaller, more accurate scale. We want approximately 2 grams. There we are. We're going to set these aside and come back to them once the timer is done with our 30 minutes and our autolysis is complete.
We waited 30 minutes. Now it's time to mix the next ingredient.
Our dough is rested for 30 minutes. Why don't we add the next ingredients? So take the lid off. And now we're going to add the salt. So sprinkle that all in there. Is it all out?
It looks like it.
Great. So that's our 10 grams of salt.
Yeah.
Now you want to add our 2 grams of yeast. Go ahead and sprinkle that in there as well.
That's all.
Okay, great job. Great job. Now that we've added the salt and the yeast, what we're going to need to do is to fold the dough over, and what we're going to do that with is our mixing hand with some warm water. This will allow the dough to be mixed, and so that we can incorporate the salt and the yeast without getting it too sticky on our hands. And don't worry about adding the extra water to the dough. It's not going to affect your bread in the end. So reach underneath it, flip it, and fold it. And you continue this process until we get all the salt and the yeast incorporated into a nice dough ball. Now, once it's there, we're going to pinch several sections of the dough like this. And then you do this about 6 times, so folding it and then pinching it. And if it begins to get too sticky again, you can go back and wet your hands. But the dough, as we begin to do this, we'll have more and more of the yeast incorporated throughout it, which will even it, and the salt as well. And again, it begins to get a little sticky on the hands. You can come in and wet it. And go back to pinching and folding. And now that we are done with this process, we are going to let our dough rest. Now that we've done folded and mixed our dough, we're going to put a lid on it and cover it for the next 5 hours. But in the first hour and a half, the dough still needs to be folded and pinched twice. It's easiest to apply these folds in the first 10 minutes and then in the next 45 minutes from this moment. We're going to then set it aside completely for the remaining 5 hours until it has tripled in size. All right, it's been 5 hours and our dough has risen quite nicely. We wanted to see about a triple in size, and that's where we're at. And some of the good telltale signs that everything's still doing well is that there's nice bubbles that are forming on top. And these bubbles here you see are going to be where you get a lot of your flavor from the bread. Now, all that's doing is the yeast is depositing, they're eating the sugars and they're depositing carbon dioxide. That's what lets the bread rise so much. Now, what we're going to do is sprinkle around the edge some flour, and on our surface here, we're going to sprinkle some flour and dump out the dough. So, here we go. Again, around the edge. This allows the dough to slide out a little bit better. All over our surface to keep it from sticking to the wood. And of course on our hands as well. So we just sort of tip this over, scrape it from the sides using our hand. We're pulling our dough out onto the floured surface. Now, it's on the floured surface. You want to give it a couple of folds. And you're looking for a nice dough ball like this. Now, what you want to do is I'm pulling back, pushing my hands in the fold and rolling it over. So I'm pulling back and rolling it over. What this is doing is driving out some of the air and the gases that are trapped inside of our dough, and we are setting it up to proof for a second rise. That's right. We're not done. Time it takes to bake one of these is usually about 8 hours in total. Now, once we've got it rolled around nice and we see some of these bubbles, these are what we're trying to drive out. Okay? Some of these gas bubbles. You can think of it like you're burping it. So, if your hands get a little sticky with it, and flour them up some more. Now, what you need to do is to put this in, you can put it on a plate, you can put it in a bowl, and what you want to do is put it somewhere where you can put a cloth over it and let it set. Now, I have what's called a proofing basket right here. And in the proofing basket, and in the bowl too, you want to give it a nice coating of flour, and this prevents it from sticking to the basket itself. And we want to basically tuck it in, put our dough, in this case, seam side down. And these baskets have nice rings around them, which will give it a nice presentation later. But we're putting it in here, putting a final little toss of flour on top. And what that's going to do is not let it stick to our cover. Now, I have a specific cover for this basket, but you can place any kind of cloth or cheesecloth, anything that's lint-free would be great to place over it. And then we're going to set it aside. Right here is just fine. And let it sit for 1 hour. Now, while it's waiting, once we've waited for about 45 minutes, you want to go ahead and preheat your oven to 400 and 75 degrees. At which point you're going to put something like this in there. This is a Dutch oven. It's my Lodge Dutch oven. It's a good size. It's an 8-quart, and this is where I do all my baking in. Now, if you don't have one of these, as long as it's oven proof, something that has a lid would be great. Just make sure that it's oven proof, that's all. And we'll get to this step next. Okay, our oven is preheated to 475, and our dough has been on its second rise for 1 hour. And as you can see, it's risen quite a bit. And what you want to do is just to make sure that its rise is complete. So one of the books that I've read on this suggests the poke test. So essentially take a finger and you want to poke your bread gently to indent it about an inch. Now when you let it go, you want the indentation to rise, but not all the way, about halfway back, like it's doing here. If it goes all the way up, it's not ready yet, and if it doesn't rise back at all, it's kind of gone too far. So make sure that you've only let this sit for about an hour, and if it needs a few more minutes, maybe 20 minutes or so, that's fine. Now what we're going to do is to transfer this to our very hot baking vessel. I'm going to retrieve ours and place it on this trivet. Now one big huge thing about safety, that baking vessel is in the oven and it's at 475 degrees. I would strongly, actually more than strongly, you need an adult to help you with this. I'm using 2 oven mitts to make sure that I do not burn myself, and I'm going to retrieve our baking vessel and place it on this trivet. The other issue is if you set it on something like a stone countertop, you could easily crack it with it being that hot. So don't put your baking vessel on something that can easily burn, like this wooden butcher block, or on stone, which can crack. So let me get that, and we'll be putting our dough into it. So now that we have our very hot baking vessel directly near our dough, we're going to turn our dough upside down. You can do this with one hand under it. I prefer just to pull it out this way. Shakes it loose. And now what we're going to want to do is, this is the very important part about safety. Again, do not burn yourself. Get parent supervision. This is not cool to do on your own. You want to scoop underneath it, and we're going to place it inside our baking vessel very carefully. And now it's inside of here. As you can tell, it's sticking a little bit on both sides, so what you want to do is, with your oven mitts, just make sure that it's separated. We're also going to take a sharp knife and make what bakers call a signature. We're going to cut into the top of it. I like the simple cross. It's a signature of the baker, but what it does, allows the bread to rise without breaking open. So we're going to cover this and place it into our 475 degree oven for exactly 30 minutes. And at that point, we'll remove the lid, leaving it in the oven to bake for an additional 10 minutes, or until it reaches the golden brown consistency that you're looking for. All right, it's been 30 minutes. We're going to put on our oven mitt, and we're going to remove the lid off of our baking vessel and let it cook for an additional 10 minutes. Remember, this is where all the chemistry is happening. So everything in the oven is changing it from the dough to the bread we want. So let's see what happens here. Again, you're going to be very careful. Make sure a parent is with you while you do this. This is extremely hot. But you can see a lot of our bread has already started to cook really well. And we're going to let it cook for 10 more minutes. So we're going to push this back. We'll shut the door. And in 10 minutes, we'll see the bread. Okay, it's been 10 minutes and we are done baking. So we're going to turn our oven off. And then again, safety first, we're going to reach in and grab our baking vessel and pull our bread out carefully. Make sure again that you're setting it on a trivet or something that it doesn't have direct contact with a stone countertop or any wood that might burn. So here we go. We've got bread. So I'm transferring the bread onto this cooling rack. I'm putting this down here so that it doesn't burn. And now, that's what we've been waiting for. So, now that we're done baking our bread, let's see how this applies to a standard chemical equation. This is a really simple scenario where we have hydrogen gas. Now, hydrogen gas is going to be something that looks like this, where you have two hydrogen atoms attached with a single bond. Now, remember, this is covalent, which means they share electrons. And if you remember from the periodic table, which, by the way, you should have in front of you, it'd be helpful. Hydrogen is number 1 on the periodic table, which means it only has one electron, and that's its valence electron. And to share it with another hydrogen atom means that each of them get two valence electrons, which makes them look and feel like helium. They're bonded together so that they can have 2 valence electrons. That's what they're doing. And we represent that with this spring in this case. So our hydrogen atom looks like this when it's bonded with another hydrogen atom to make H2, hydrogen gas. We're going to add that to oxygen. Now, oxygen is going to look like this. Remember, oxygen gas, which is what we're looking at, is in the oxygen family on the periodic table, right here. It has 6 valence electrons and wants 2 more to look like neon. But again, this is covalent. So what they're doing is each oxygen atom is sharing 2 electrons with the other oxygen atom so that they look and feel like their valence shells are full. But again, they're 2 nonmetals and what we call a diatomic, 2 atoms, just like hydrogen gas, to make oxygen gas, or O2. So that's what our molecule is going to look like, our model here of oxygen gas. Now, remember, the very last class we had on Friday, we talked about this arrow. We're not going to call this arrow an equal sign because it's not an equal sign. These 2 things are going to make something new. Just like our bread, we had ingredients that's going to make something different than what the ingredients looked like before we baked our bread. So instead of calling that an equal sign, we're going to call it a yield sign. Now remember, our yield sign, right here, is just an arrow. And that yield sign is going to describe the direction of the chemical reaction. So we're moving from the left side to the right side. So far, so good. Now we have to add in the liquid water. And in this case, good old dihydrogen monoxide is what we're going to use. And we're going to put the molecule together like this. We have 2 hydrogen atoms sharing 1 electron with the oxygen atom, which needs the 2 to be complete, just like we explained over here. So now we have a water molecule. So far, so good. Now, what we probably want to do is label each side of our chemical reaction. Since our yield describes the left side moving to the right side, we want to label those sides. So what we're going to call them is the left side. where we have our ingredients, we're going to call those the reactants. And on the right side, what we're going to call those? We're going to call those the products. That's what we made. We made water, liquid water, from two gases. But just like I've described before, I think we have a problem here. On the reactant side, we have two oxygen atoms. But on the product side, there's only one oxygen atom. That's a huge problem. The reason it's a huge problem, as you're probably thinking, is because it violates the conservation of mass and matter law of the universe. We can't have something that just vanishes from one side because we can't create or destroy, in this case, new matter. So what we're really missing here are the proportions. Now, remember, we had different ingredients to make our bread, but to get to the actual loaf of bread, we needed certain proportions. That's why we were measuring things like 500 grams of flour or 10 grams of salt. Those were important proportions. So what we're going to end up having to do is to make more of these ingredients to make more of our product. So in this case, if I need another oxygen atom over here, I can't just throw it in the mix. That wouldn't make any sense because water is H2O. It's not H2O2. So what I'm going to do is add another water molecule. Now I have two of them. And I can look here and see that I do have two oxygen atoms, which is what was needed. So to represent this in our chemical equation, I'm going to put a 2 because I have two water molecules. 1, 2, two water molecules. This number is called a coefficient. Now, we've also created another problem. The problem here is that I've also now added two more hydrogen atoms. So, if I look to my reactant side, I've only got 2 on this side, whereas on my product side, I now have 4. So, hydrogen was fine until we brought in this extra water molecule. We need to fix that problem. So the best way to do it is to bring in 2 more. So now we have 2 hydrogens, the diatomic molecules, and we're going to represent that, as you probably guessed, with a 2. So now we have 2 hydrogen molecules plus 1 oxygen molecule is going to make 2 water molecules. And this is how we break down the anatomy of a chemical reaction. Well, that's the end of the lesson for today. If you were paying attention, you now know how to write chemical equations, you know the parts of the chemical equations, and you know how to maybe even bake some bread at home. Give it a shot. Let me know what you think on Schoology. Until then,
thumbs up if you like this video.
We'll see you Thursday, gang. Have fun. Stay safe. Love you guys.